In this video, I want to quickly go over through things I want to learn next year as a developer, as a full stack developer, and things which are not your conventional things, right? Because once you are at a level when you know a lot of things about front end and back end, it might seem like there is not a lot to learn about. But with my experience of working and building on production applications, there are a lot of small and medium sized things you can always keep in your to learn bucket list. And this is just one of the insights you would not get until and unless you're working on systems which are big enough, and that's usually very hard to do in a personal project. It usually happens when you are in a company or in an organization where you have a lot of visibility into the product internals. So I'm just helping you out with my viewpoints, with my opinions on what I think are some interesting and important things which I would probably consider learning next year. Now I have this very basic representation on, 3 columns. Basically, I think it's better if we just align them like this. So this is basically, this one is things I knew already. This one is things I learned this year, which I feel are, somewhat important. And okay, let's see. And this will be the section which is what I would learn next year. Let's talk about 2023. Now, one of the big things which we did this year is that we took CodeDamm's database from MongoDB to Postgres. So basically what I learned in this is a lot of SQL syntax plus Postgres syntax. MongoDB's world is very different from SQL world. So we had to dig into tools like Prisma, for example, Kaisli, Drizzle. So these are all like query builders and ORMs, which are mostly popular for interacting with SQL databases. One thing, Prisma I see is improving every day with every release. But one thing which I understood is that Prisma is still, it's like it's taking a cannon or it's taking a rocket launcher to kill a insect. It still feels like that because it's over bloated. It's a lot, it includes a lot of runtime. Still, I feel even after a lot of optimizations and things here and there, if you are probably looking for a lighter weight, simpler implementation, I think Kaisli is something which we use and I can say it works. The problem with Kaisli, which we eventually now figured out after a few months, is that because it's so heavily dependent on types and TypeScript, generally, if you are writing some level of complex queries, it basically kills your IDE, right? So, the complexity, we don't exactly know where it comes out of, but Kaisli, because it uses a lot of generics, and in TypeScript, generics, I believe, are expensive in terms of runtime computation on the developer side. It becomes very expensive, and in our code base, in CodeDamn, we do have a few files which are basically dead. Now, when we say files are dead, that means that the TSC compiler doesn't work on it. So, it will work if you invoke it via CLI and it will take a minute or so. But if you are working in VS Code, you can basically forget about IntelliSense and ESLint and all that good stuff, right? So Kaisli does that, right? I don't know what's the fix for this while keeping the type checking and type safety within like Kaisli syntax. But maybe a more like a builder pattern or something where real JavaScript objects are used. Maybe that could be a better alternative than depending on TypeScript all along, right? Another thing which we discovered with Kaisli was that it doesn't support relationship checks, right? So even if you have in your Prisma schema, even if you have like foreign keys between 2 columns, Kaisli doesn't really enforce that. So you can technically, SQL also allows that, so it's not exactly Kaisli's fault, but there is no help. So we had to write our own custom utility on top of Kaisli, which after the build, it's like a CI process which just goes through the full code base and checks if all the relationships are correct. So just a couple of gotchas with Kaisli we have seen so far. The rest of the things are pretty smooth. Prisma, on the other hand, not sure like how all of that stuff works. Kaisli is good. It's nice with a few gotchas, right? So, the star for the gotchas and check is like, a tick mark emoji. Now, working with Kaisli and Prisma this year, and especially Kaisli, what I realized that one thing which is a very powerful concept in generally in TypeScript is TypeScript generics, right? And how does TypeScript internally works with, those all sorts of constructor pattern where you can use infer and extends and, you create all sorts of complex codes. I know basic to intermediate TypeScript. I understand how to fix errors. But if you ask me that I could understand how Keisli works, how Keisli's code base works, I wouldn't know that, right? And even if I would know that, I wouldn't know if this is the best way to implement a particular thing. So we have like one utility I already mentioned to you. We have like a couple of more patches on top of it. But yeah, these are like sort of patches, which I'm pretty sure that if somebody who knows like TypeScript 0 to 100, they would probably know a lot better in terms of like how can we optimize it even further. So TypeScript generics plus advanced TypeScript, something that looks like programming within TypeScript, even though TypeScript is a meta language, is something I would probably consider in 2024 next year. Similarly, on top of this, now again, this is not exactly an exhaustive list. It's more like a brainstorming session with you. So TypeScript is something I already knew, but of course, like going next step further, advancing next step further is what I want to do. Another thing which I learned this year, which was very interesting, was prompt engineering. Now, when you think about it, it seems stupid to, have something like prompt engineering. Okay, you just have to tell an AI model what to do. But it's just like Google search in a way, that if you are writing full sentences or if you don't know how to search for something, it's very likely you would not find it. Similarly, especially with models like GPT-4, if you write the prompt in the exact way, and if you're doing like good follow-up prompts, if you're brainstorming and debugging properly with the AI engine, this is something which can give you a lot more reward, right? So because if you let AI know exactly what your requirements are and how it should be worked, you should know like when you should give examples to AI. For example, let's say if you want it to write a simple TypeScript application that takes in a file, does something to it, and then spits out another file, maybe JSON to XML, right? Now, this is a very common example, but let's say if you have a custom use case, I would probably just manually create an example and give it to the engine, right? You might just, if you're doing this for the first time, you might just not do it, or you might just do it, in a different way. So learning about these zero-shot, one-shot prompting, when to use what, how you should talk to an AI so that you don't waste a lot of times. What are tokens and why tokens are important? What is exactly the memory of this model? Things like these are like all of them combined is what I would probably call as prompt engineering. Because let's say if you think like you can just take it everything step by step, that's also a pretty bad approach, because at some point you will run out of the memory. And it has been shown with experiments that the retrieval of the AI model is much better in shorter context windows than longer, right? So you don't want to just keep on talking to AI over and over again, because it starts forgetting. So you want it to do your work quickly, crisply, and as fast as you want. Now, talking about this, what it makes me realize what I want to learn in 2024 is a little bit about how these models or LLMs work internally, basically. Right? So, I mean, this lies more on the research side of things, but in order to, just phrase it a little bit more better, how do we deploy open sourced AI models properly with understanding, right? That's important. I mean, I can of course follow along a README and just do that and do this, but until and unless I know like what are the performance factors, how do we speed that up, how do we do this, how do we do that, and so on. This is something I would probably want to consider next year, because LLMs, AI, this is very expensive technology, right? If you look at GPT-4's pricing, for example, it's very expensive. We offer that under codedamn Pro. By the way, this is what I'm talking about. So if you go to codedamn.com/AI, you have like a full AI teacher available to you. So if you open any of these languages, you can start debugging them pretty much like right away, right? So this interface in itself uses GPT-4. But I don't know about, the open source models which we can use, and maybe even at some point next year surpass GPT-4 in terms of the quality. So all of that is something which requires a little bit more insider deep knowledge with LLMs, which I probably want to learn next year. Now, of course, something related to this, which I already knew, was probably, I would just say, API calling, manipulation, etc., whatever. Right? Because of course I knew how to work with GPT API, Claude API, Anthropic, all these companies' APIs. But at the end of the day, you are not an AI company, you are an API company if you're just calling these APIs. Of course, you can combine that with prompt engineering and it leads to a lot more quality output. But still, at the end of the day, if you want stability, reliability, and cost effectiveness to your systems, you have to deploy these models on your own, right? On your own infrastructure. Another thing which I learned in this year was monorepos. And again, this comes from the fact that codedamn migrated all of its repos. We used to have a polyrepo structure where we'll have every single repo in a different repo, every single code base in a different repo. And we shifted that. We changed that to monorepos. So now for front end, we just have a single monorepo. And for backend, we also have a single monorepo. We are not combining it right now because of challenges which are between front end and backend. And we don't exactly share a lot of code base as well between front end and backend. But when I say backend, what I mean is basically everything, right? So from the actual backend API where you call, from our cron jobs, from our webhooks, from our, these streaming APIs, which are AWS Lambdas, which talk to these APIs, open API directly and then stream the response, from our image compression things, everything is backend. And then front end is, of course, all these Next.js projects on codedamn, maybe debugcode.io, maybe some other websites which we have here and there, internal tools and so on. So monorepos is very interesting, but to be very honest, I would say that the tool like Turbo, for example, it's a huge tool, or Turbo or NX when you talk about these monorepo management tools. Currently we use Turbo, but I wouldn't say like we use Turbo a lot, right? We just use a few parts of Turbo. We use the Turbo cache. We use some build steps which allow us to skip certain builds, some verification steps which are powered by Turbo. But I don't personally understand Turbo like I would say I would understand JavaScript, let's say, or SQL. So this is a technology which I would probably want to invest a little bit more time next year. What exactly is Turbo's benefits and how do we leverage it to the maximum? Because it can save a lot of time, right? It can save a lot of build time. It saves a lot of things. Turbo, I think one of the quotes which they mention is that you should not recompute anything twice, which I think is pretty cool, but it's very aggressively efficient. So yeah, that's something on my list. Similarly, with monorepos, something which I learned again this year was PNPM, which is a package manager I absolutely love now after we have migrated to monorepos. I have not used PNPM before. I have read about it a lot. I know, I knew so things I knew already, PNPM theory, that it uses hard links and it saves disk space and what it does, why it does, all of that. But after using it, it's not only very stable as a tool, it's a very strong tool. It feels like you're working with a good app. You're working with a good production ready application which is built for monorepos. Something I absolutely did not feel when we were using Yarn. So in our polyrepo structure, we were using Yarn with every single repo, and shifting it to monorepo was a nightmare with Yarn, right? Just the documentation and everything. I mean, maybe I did not spend enough time with that, but we could not figure out how to make it properly work with Yarn, because Yarn would just hoist everything at the top inside node modules. There was no scoping inside workspaces. The definitions were a little weird. So we just dumped Yarn completely, shifted everything to PNPM. I think we wasted at least 2 to 3 days because of just Yarn, because we tried to make it work, but it didn't work. So PNPM, super interesting, super amazing. What I want to see is if there are better ways to work with monorepos. Bun is a very interesting choice for working with monorepos because of obvious reasons, that package installation and everything is super fast in Bun. So, but it comes with a huge question mark because of if you want to know in details, you can also watch one of the videos I made that I tried Bun for 100 days. But yeah, I mean, Bun is a technology which keeps on giving. So it's improving every single day, every single week. And I want to see where it ends up in terms of monorepo support and in generally as a runtime next year. So I'm curious to see how Bun plays out. Now, one more thing which I learned this year, which might not exactly be related to programming, a lot of you might not agree also with that, is about emails. So what exactly did I learn? I mean, if you start looking deep into emails, now, of course, I was coming from an email marketing point of view. It's a great way to reach to your audience. It's a great way to build a following. And if you want to inform them about anything, emails is a great way to do that. But emails are very deep in nature, right? There is a lot of technology involved. So DKIM records, SPF records, DMARC, there is also a BIMI record. So all of these records, how does this work? How to not make your emails go to spam, how to use subdomains in emails for classifying email categories. Postmaster, this is also an amazing tool. So these are a few things which I learned in 2023, and I'm interested in continuing learning more about emails generally in 2024, because it's a very strong way. I mean, even at codedamn, I've seen a lot of people read our emails, a lot of people respond to our emails as long as they are delivered to inbox. And there are mistakes we have made. There are things, we were not careful about, we did not know about, which then probably led us enter into more of a spam zone, a spam category. And then, a lot of those were technical challenges also. A lot of those were, things like, for example, not including list unsubscribe headers. So when you are using your own custom stack like we do, so at codedamn, when you get a marketing email or any transactional email, that's actually going through our own code via SES, AWS SES. But the code which dispatches the email, it's our own, right? So it's not a listmonk, or it's not a Mailjet or any sort of CRM sort of thing where we manage and handle list subscriptions and everything. Everything happens on our own Postgres database, right? So if you want to unsubscribe, if you want to resubscribe, we control all of those gears and knobs within our own platform, which also, is one way to fire yourself in the foot, because now if you don't know about things like these list unsubscribe headers, then of course your spam rate would increase, and people will start reporting more of your emails as spam instead of not being able to unsubscribe. And it's just you just have to get a lot more technical if you want to build your own path. And that's what we did a little bit. I did in 2023, but that's something I want to continue in the next year as well. Now, this is a pretty casual video. I did not think about a lot of things up front which I want to learn, but one of the things which again comes to my mind, which I want to explore, if I'm not sure like if I'll buy that or buy the equipment or anything, but what I want to explore is the Vision OS on on the Apple AR VR headset, right? And this is interesting because Apple is one of those companies which is known to make quality products, and if it's bringing its own virtual reality headset and the operating system and all the batteries included things around it, people are gonna buy it, right? And when people buy this equipment, it unlocks a new level of market for apps which can, for the first time ever, like make use of three-dimensional space instead of just 2D space on screen. So what applications does it unlock in terms of whether it's how to learn coding, or in general about anything, games or any sort of area? This is something which I want to explore as a personal thing next year. What I also want to explore next year is actually getting a little bit better at some sort of low-level language like Zig or Rust, right? Because Zig, again, it's something I came to know about with Bun. Rust is, of course, like a very popular thing. I'm not good at either of them. I mean, Hello World is fine, but if you're just writing Hello World or, just swapping variables, you're not a programmer, right? You should probably be able to write medium to large size complex applications in order to say that, hey, okay, let's just migrate this one service from JavaScript to Zig or Rust. Now, the reason I say that is because we have a few workloads on codedamn where the code base has to be fast, right? It has to be ridiculously fast. And in some of those use cases, we actually hit the JavaScript limit, right? For example, one of the things which we feel could be much faster is our custom DNS. So we have our own custom DNS provider for the codedamn.app domains, which you get on Playgrounds, right? So what I mean by that is if I go to codedamn Playgrounds, and if you boot this playground right here, the moment I click this button, it will start a new playground, right? It'll just navigate, it'll just take a quick second, and it'll navigate me to this interface. From this particular moment, since the playground is assigned to me, to the point where you see this URL and all these files and everything opens up, the DNS, which resolves this domain to an IP address, we control that DNS, right? Not Cloudflare, not Vercel, not nobody. We control this DNS. So the glue records are the EC2 servers which we own. And unfortunately, that DNS is actually written in JavaScript, which I mean, it's okay. It's okay for us to write it, and it's something which works. I mean, it does work. It's not like it's not working or anything, but it's more or less it's a less I would say faster implementation than what we can have with natively compiled code. And it just seems like that an application like DNS, for example, should be written in the best optimized code possible, because it should be able to take a lot of hits, a lot of requests per second. Even though we don't end up implementing, changing JavaScript to Zig or Rust, it'll just be a good thing to have. It's just knowledge never hurts. So yeah, that's basically it for this one. Very simple, very raw video format. I hope you like it. I hope you understood like a lot of things which I mentioned here. So yeah, that's basically it for this one. I hope you liked it. I hope you understood most of the things which we discussed. Let me know your own bucket list, your own things you want to learn in 2023. It doesn't matter if you're a beginner, if you are somebody who's intermediate or advanced. I would love to know if I can steal a few topics from you and add them to my list as well, because to be very honest, it's looking a little bit ridiculously short.